Hi everybody and welcome. Today's video is going to take us through a start to some of our study guide questions. So after watching this video, hopefully we'll have a good grasp of the concepts for 2.1 through 2.5. We'll have some extra examples to practice and it should give us a head start on checking our work for the study guide as well. So starting off here, looking at some systems. So systems of two equations with two variables, so we are going to be able to solve these. And a couple of different methods that we use. We had substitution, where we plugged in, and we had elimination, where we lined things up and straight down. So for number one, we have a variable isolated. We have a y equals, so this will probably be a good idea to substitute here. So we have y equals 1/2 x, so we can plug in that 1/2 x into that first equation. So we'll have 1/2 x here equals 2x minus 3, and now we can go through and solve. So we can subtract 2 from both sides here, and we have a choice, so we can simplify this with fractions, or we can put this into the calculator. So 1/2, we can write that as 0.5, and what we're going to see here is that's going to give us negative 1.5 x equals negative 3. You can also write that as, if you did that out in fractions, if your mind works like that, it would be negative 3 over 2. Because the 2, we'd simplify that to 4 over 2. We'd have common denominators, then we could do that as well. Either way is totally okay with me, but don't get lost in that part of it. Focus on the solving the systems aspect of it. So here we're left with x equals 2. All right. So don't forget, when we're done, we still need to solve for y, so we can plug this back in. So y equals 1/2 x, or y just equals 2 over 2, which equals 1. Okay. So there we go, we have x and y. That's an example of substitution. Number 2 is an example of elimination. And I'm actually going to come back to that. I'm going to allow us to do that one on our own because I think number 3 is a better example to go over. So if we take a look at number 3 for elimination, so we're going to try to eliminate here. If we're trying to eliminate and get a minus 3y, we'd have to multiply that entire first equation by a decimal. Now we don't want to do that because that's going to make things really messy. The same thing if we wanted to eliminate 5, we'd have to multiply the second equation by 2.5, or another decimal. So we're going to avoid both of these things, and we can focus on canceling out one of the terms. So if we say, okay, I would like to eliminate y, we can actually use our LCM, least common multiple, to do this. So multiples here, we have 2 and we have 3. So 3, 6, 9, 12, that's an example of the multiples. 2, 4, 6, 8. We can stop there because 6 is the least common multiple. So our goal is to have one of these equations with a positive 6 and one of these equations with the negative 6. So we can multiply the top one by negative 3. We can multiply the bottom one by positive 2, and that'll give us a negative 6y on top and a positive 6y on the bottom. So sometimes you'll find a system with elimination where you won't be able to just multiply once. When you do have to multiply both the equations, use the LCM method described here, and you'll be able to successfully solve. All right, so the top equation, negative 15x minus 6y equals negative 33. The bottom equation, 4x plus 6y equals negative 12. Now let's line these straight up and straight down and see if we were successful. So we get negative 11x, 0y, perfect, it worked, equals negative 45. All right, so we have an equation here of negative 11x equals negative 45. So check our work real quick before we go on. We did eliminate, we achieved our goal, which is exactly what we wanted to do. In each of our terms with the positives and negatives, again, we line those up straight up and straight down, and we did what we needed to do. Okay, so here, divide both of these sides by negative 11, and we'll get that final answer of x equals positive 45 over positive 11. Those two negative signs cancel out. All right, so that's our final answer. It's okay if we leave it there as an improper fraction. That's totally fine. So the last step would be going through and plugging this in and solving for y. So again, if we were to choose that second equation, we'd plug in that term for the x value. We'd go one step at a time. We'd also get our y equals here. Okay, so finish that one up. We'll take a little bit of work with that fraction, but we'll be okay. We can simplify it to a decimal. There's a bunch of different options to solve there, but the big focus for this one is multiplying by the least common multiple there, and we'll be in good shape. All right, another example here are word problems. So for these word problems, the annotation and organization is very important. That is a procedure for us here. So first we need to write down what we know. So we know that we're going to buy 25 items. We know that pizza rolls are $1.99. We know that coffee is $5.50. And we know that the total is $102.40. So again, if we were to sort this information, we see some price information and we see some quantity information here. So we should have enough information for two equations, a price equation and a quantity equation. So quantity, we're going to buy rolls and we're going to buy coffee, and in total, we'll have 25 items. And our price equation, just under $2 per roll plus $5.50 for each coffee, will get us the total that we spend, which is $102.40. And then now we can either eliminate or substitute to solve. So we still need to solve for R and C. And I'll let us do that so we can see, again, have some practice going through questions where maybe we have some decimals, but we can still go through and do this. All right, next, a system of three equations. Now, we've had 3 videos on this, so I would encourage you, if you're not feeling good about this, to use those extra help resources that we have posted on Classroom there, and that's going to, again, help us go through. I posted one video that went over some additional examples, and I also, with that video, posted a worksheet of, I believe it was like 4 extra questions to practice. So use this time, use those extra questions, and that'll help you be successful. We will go through here this example. Like we said in that extra help video, our goal is to eliminate one variable. Our goal is to form a new system with 2 variables and 2 equations, and our goal is we have to use each equation once. All right, so we have equation 1, 2, and 3. Looking at these here, we can either eliminate x's or y's, even z's. Any of those would work. Each of them are going to need to do a little bit of work in order to eliminate. So let's say we can eliminate our x term. Let's just do that. So we're going to eliminate x, and we'll start off with equation 1 and equation 2. I think my marker is not working here. So maybe the Apple Pencil died. All right, we're doing it. Wow. Apologies, everybody. I don't know, my technology is failing me right now, but we'll be okay. All right, looks like we fixed it. Equation 1 and equation 2. All right, so x plus y plus 2z equals 8, and 2x plus y minus 3z equals 0. All right, so to eliminate the x term, we need to have a negative 2x, which means we need to multiply our first equation by negative 2. All right, so negative 2x, negative 2y, negative 4z equals negative 16. Line these up and straight down, and we will get negative y. Again, technology is failing me, but we'll power through. So again, negative y here, we got 0x, that canceled, negative 7z equals negative 16. So that's equation A for us. Again, negative y minus 7z equals negative 16. Okay? And now we need to eliminate x again. And we need to make sure that we use equation number 3. So we'll use equation number 3, 5x plus 3y minus z equals 14. In order to eliminate, we do need a negative 5x term. I think the easiest way to multiply would be to multiply equation number 1. So again, we're allowed to repeat one equation. I think the best strategic move for us would be to repeat equation number 1. Again, apologies for, I don't know what is going on here with the iPad, but we'll be okay. All right, so hopefully we can get this fixed here, but Again, our goal is to multiply to get a negative 5x term there. All right, so let's see if that worked. All right, looks like we're back in business. So multiply the entire first equation by negative 5. We'll get negative 5x, negative 5y, negative 10z, and negative 40. Do these things, line them again straight up and straight down. And we'll see 0x, negative 2y, negative 11z, and then negative 26 is our answer there. Okay, so that's equation B. So now we have our new system to solve, and the new system is negative y minus 7z equals negative 16, and equation B is negative 2y, negative 11z equals negative 26. All right, so now use either substitution or elimination. Solve for y, solve for z, and then plug it all the way back in to solve for x. And if we do that, we'll be in good shape. We'll have solved this one, but again, we achieved our goal of eliminating a variable, creating a new system, and using each equation one time. So that is kind of the purpose of doing systems of three equations, is to go through and to achieve those three goals. Okay. The final question that we're going to look through today is graphing systems of linear inequalities here. So the first step that we want to do for each of these equations is to put it into y equals mx plus b form. So we'll subtract 3x from both sides. Negative 5y is less than negative 3x plus 20. We're going to divide here by negative 5. Remember, when we divide by a negative, that does mean we flip our sign. So y is greater than 3/5 x minus 4. Okay, so that's one equation. Our annotations for this are that it is dashed and above, because it's greater than. We start at b equals negative 4, and our slope, we go up 3, and we go over 5. All right, so we can graph that one now. So we'll start off at b equals negative 4, go up 1, 2, 3, over 1, 2, 3, 4, 5. Got to remember to keep things dashed. And again, we're shading above for this one. All right, second equation, do this one in green. We have 4x plus 3y is greater than or equal to 9. Again, solve this in y equals mx plus b form. So I'll have 3y is greater than or equal to negative 4x plus 9. Divide each of our terms by 3. Again, we don't divide by a negative here, so we don't need to change any signs. So negative 4 over 3x plus 3. Our annotation, greater than or equal to, means that we are solid and above. And secondly, we start off at b equals 3, and then our slope, we go, we'll call it negative 4 over positive 3. So right 3 down by 4. So start off at b equals 3, we go down 1, 2, 3, 4, and then right by 1, 2, 3. So down 1, 2, 3, 4, right by 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. All right, so we can draw our solid line. We're again shading above, and our solution to this is the shaded region. And maybe we can even highlight it, so we'll do it in blue. So this entire shaded region here is the solution to our system of inequalities. And that's going through a full example there. So again, key steps for this one is just make sure it's in y equals mx plus b form. It'll make graphing a little bit easier. And don't forget about those annotations. Again, important to know, is it a solid line, is it a dashed line, and where do we start, and what is our slope? So all of those things put together are going to make us more successful solving these questions. All right. So checking everything over, it looks like we're in good shape. Any questions on these, as always, feel free to reach out. Also, bookmark a few questions if you want to go over one or two of these before we start the test tomorrow in class. Have them ready to go. Ask me them, and we can go over them as a class during that time too. Appreciate everybody watching. Good luck. And